Thank you, everyone. Yeah, you will see that my talk is very different than the kind of talks you've heard so far, and you will see throughout the day. At the end of the day, I'm a computer scientist. I work in a group that's entirely built of AI researchers and machine learning scientists who do not have much background on the learning scientists at all. So you might nod your head on some of the algorithms that I'll be presenting today. Sometimes maybe in a good way, sometimes in a bad way. As I go through my presentation, you will see the flavor is mostly from a perspective of a lifelong learner. And this comes from LinkedIn being a job site, the workforce also changing, and not only that, students not just limiting themselves to academic education or academic resources, or getting degrees from their respective universities and limiting themselves to just that to find the jobs or the kind of roles they're looking for. So let me start with this slide. The problem of skills gap is a real problem, and this is especially true the more you have stayed in the industry, the longer you have stayed in the industry. The skills you have are no longer relevant, and on the other hand, there are new skills that are demanding, that are running shortage of workers because there are not that many people with the kind of skills that can fill up these open positions. So the need for lifelong learning is inevitable. Learning does not have to stop after school, and I think that's the flavor of most of my talk here. And students or professionals need to complement their education, college education, or reskill themselves to find the job they're looking for, or to transition into a dream job, or to just keep up with their current careers. And I think coming from an entirely techie background, these have been mostly the kind of companies we have seen in the past. Lynda was one of the earliest ones, which was started in 1995 for a video version of DOS for Dummies. And then later on, we have seen a lot more companies emerge in this space, and we call them the online learning platforms. In conjunction, research in this world also has grown, along with educational data mining. We have learning analytics. All of these conferences are very recent, and they've been looking at the data collected from the learners from these platforms and trying to analyze what learners really want. And LinkedIn Learning is one of the latest among all of these things. I don't think it is the latest, but it's one of the latest one. It borrows a lot of content from Lynda, and the vision was to actually bridge the gap between people looking for jobs and matching them with the right content so that they can actually find the jobs they're looking for. But you will see that the talk here is actually more generic than that. It's not limited to LinkedIn. I don't mean to be a LinkedIn advertisement here. The algorithms that I'll be presenting are mostly adopted commonly in the industry by any online learning platform. There may be small different flavors of it. The terminology may change. So the talk today will cover 4 main subtopics. One is search and personalization, which is sort of the foundational algorithms. Understanding the content we have on these learning platforms. Either they are user uploaded or they are generated by instructors themselves. The micro-learning field, and then finally learning paths. So let me start with search and recommendation. It's one of the foundational algorithms. Learners need to come to a platform and find the content they're looking for. Search is one such subfield, and also recommendations is one such subfield. In search, you're able to type in a certain set of keywords and find the courses or videos that you're looking for. And with recommendations, you actually, when you come to the landing page, you already have things that you ideally want to learn. There are 3 types of personalizations we do here. One is the actual course recommendation. The second one is the annotation, why that course was recommended for you. And the third one is ordering of these annotations so that you actually look at what you're interested in on the top. The recommendations also serve as an acquisition channel by showcasing parts of the catalog to either ad channels or within the website acquisition channels. In our case, it's feed and jobs. So when people come to view a job, you can see what kind of courses would be relevant for that job. When people come in onto their feed, they can see what kind of courses they recommended, and it serves as an engagement as well. There are 2 parts of these recommendation algorithms. One is before you have any actual learner data on their learning behaviors. And then the second part is actually when you actually have the learner data. So now I'm going to start diving deep into these algorithms, one from recommendations, mostly for recommendations, and then mostly into classification algorithms. So the cold start model is the model that we use where we don't have enough learner data. But overall, this is the this is the flow. Like anything that you do, any sort of AI work you do in the industry comes into two parts. One is the online and the offline. The online portion is where you actually serve these recommendations to the front end or the app, but the heavy work happens in the offline world because you have huge amounts of data that you need to crunch to come up with these recommendations. And all this happens either on a Hadoop cluster or a Spark cluster or even TensorFlow clusters. And these recommendations are finally pushed to a read-only store, which are very fast, a read-only store because the reads are very fast. The writes are slow, but the reads are super fast, and these are like any key value store that you have out there. So this is sort of the overall workflow of any recommendation algorithms that we see online. If you just draw any parallels with any other self-driving cars or chatbots or anything, you'll always find these two components to it. So I'll be focusing more on the offline because that's where all the interesting, all the magic happens. Most of the magic happens. So the offline only model also sometimes is used for engagement through emails. Like if you get recurring emails from Coursera or from LinkedIn Learning saying, hey, these are the courses recommended for you, they're coming from these offline flows. So the very first model, like I said, is a cold start model. We call them affinity models because we try to map it to a nearest dimension and then do a matching there. And skills is the currency at LinkedIn. Everything is mapped to skill. Jobs, people, skills, companies, any entity you have in LinkedIn ecosystem maps to a skill because skill becomes the exchange currency. Courses also map to skills. And so what we end up doing is we map these two skills and then you can do a very basic affinity score. There's a risk that happens here is that you can get basic C, advanced C, C with pointers, all the courses recommended back to back, which is not useful. So you want to diversify your recommendations. So you have a diversity pipeline at the end of it. There are some small challenges around that. One is, of course, when you have limited member to skill mapping. This is typically the skill mapping that you have. Most of the skills are, this is my profile and there are some of my skills that have been added, some endorsements over the past. But only 30% of the member base actually explicitly put their skills in the profile or keep them updated, which is a problem. So then we use the network here, which is unique to LinkedIn, which may not be the case with other learning platforms. But here we do have other information about you, like title, the people that you are connected with who have similar titles like you. So we can kind of average out the skills you might have from that. And so this usually doubles the number of coverage we have and increases the number of recommendations we can make even when you don't even have even a single watch behavior from you or click behavior from you. But once you have behavior like watch behavior, you can actually train a model. And this looks a little more dangerous than it is, but essentially it's member data, which is learner data, course data. You can derive features, you can derive activity features, which can also serve as label data. You obviously have to subsample the negatives, and you can train a model. And logistic regression is the very first model we tried, but I'll start going into the evolution of the algorithms that we have tried over the past. But the features often include, course features, which could be author, category, skills, type, and CDR features. The demography features of a learner, whether they're job seekers, where they are, and so on and so forth. They could be engagements, they could be similar courses that they've watched, the kind of courses they've seen, or people who are like them and their activity. So these are all interaction features, or we call them the cross features in the lingo of LinkedIn. Now I'll briefly go through the evolution of algorithms. The very first thing anyone tries when they want to do recommendations is the classic logistic regression. It's easy to train, it scales well, and it has been hashed out at a horse that's beaten to death. So you'll always get recommendations that make sense with this. So there are three types of features in here: the member features, the course features, and the cross features. And then you learn essentially a weight and a bias term, and you use that for making recommendations. The other school of work that has been going on is decision trees, the XGBoost, random forests. What you end up learning is a decision tree from your features again, and when you run when you score a new member course pair, you get a recommendation whether that member will be interested in that course or not. What we have done at LinkedIn is taken it a step further. We have hyper-personalized using the about to in order to create more personal recommendations. So the very first one is personalizing the features itself. So let's start with the very beginning features. We have member features, course features, and the cross features. Let's run it to a decision tree. And now what we use here is actually something very unique. We look at the paths of these decision trees, and each path becomes a feature. So at scoring time, now you have personalized features for each member as opposed to just a generic feature that everyone gets. And so leaves are now interaction features that are personalized. So you don't have to mind whether someone's demography, someone's skill would be useful for that course, or this course category would be relevant for this member title. You're automatically mining these features on the go because the decision tree has already mined these things for you. and then you can train a logistic regression on top of it. So now you have a hyper-personalization model where the features are personalized for a particular member. The other type of personalization is generalized linear models, where you can have a global model. We call that the global model, where we have one bias term and one weight term for the entire member course population, and then now we have a member-specific model and a course-specific model. These are smaller models. So if I want to look at, say, the member seniority level, right, and then I can have the member seniority level there in FM, and BC becomes the course level model. So course ID times the member the member seniority level, and then I learn a weight on that. So I can now learn interactions there by training those, and you use a basic EM algorithm. You keep this model, this part of the features constant, and then you can learn this. You can keep this constant and learn that, and you do this in a loop, and then you can learn the features. And this also gives you hyper-personalization. We call this the global model. We call that the per member model and the per course model. Now let's take it a step further by combining the decision trees along the generalized linear mixed models. So we start with the original features. We train a decision tree, and we get interaction features that are hyper-personalized. We use that as a global model, and then we can have per course and per member model. So these have given us more and more personalization over time, and this has been the evolution of our algorithms. I mean, in here, I wouldn't want to underplay the role of TensorFlow and the deep learning. What we call them there here is deep and wide networks, where we can train these member embeddings and throw them in as features in the model, and then you can now create interaction features from them, and so on and so forth. So although we still use TensorFlow and other deep learning models under the hood, it still comes up in this overall framework where we have to do personalization. The scoring pipeline is not as straightforward as we at first thought. We just thought, we can rank every member in every course, but we have 600 million members and 30,000 courses, and I can't imagine any other learning platform to have a smaller number as it grows. And so it's not possible to always rank every course for every member. So we actually look at candidate pools, reasons why a certain candidate course must be a candidate of recommendation at all. These could be you have taken a course before, similar course before, or it could be based on your title, based on your industry, based on your watch history, based on your interests, and so on and so forth. So these are candidates of courses that must be ranked, and then you pass it through the feature generation pipeline and scoring pipeline. So that covers more or less the recommendation algorithms. I want to briefly talk about the carousel ranking. So remember, we have carousels that are ordered by annotations, and each annotation means a reason why a course is recommended to a learner. What we learned was the carousels are not always equal. So for example, some carousels where trending in your title are more valuable than trending in your industry. They have more click-through rate. So it's quite possible that a learner is more interested in skills-based recommendations versus a new course recommendation, right? And so they can be personalized as well. So we use a smoothing algorithm where we have a global click-through rate for all of these carousels, and then we smooth them over with the member-specific click-through rate for each of these carousels. So then now you personally may see a skill-based recommendation higher because you're following certain skills. Or some other person may look at a hobby-based or a trending and title-based recommendation at the top. So this has been more or less the algorithms, but then these algorithms have also helped us enable learning at workplace. And this alludes to some of the talks that Mitchell gave about anonymity or about wanting to learn without having anyone know that they're learning. And this is something that we learned along the way in enterprise products of our learning. We wanted, although LinkedIn as well as the learners, as well as LinkedIn, both benefit by learners having a member ID that's tied to their profile. So we can now learn about what their interests are, what their activities are, and use that for recommendations. A lot of people are very uncomfortable using their LinkedIn profiles. So they had to have, it's a project called Project Unbound, where employers can invest in the professional development in the workforce, but the employees don't want their employers to know what they actually learn on their LinkedIn profile. So they had it's called the Project Unbound, where they were not bound to a LinkedIn member ID, and they could have their own separate profile ID that they could use for learning what they needed to learn. It also can be a platform for disseminating information, onboarding material, and this is very common if you think about manufacturing industries, where you need to upload some safety videos for any new worker who joins a plant, who wants to start operating machinery. They need to see these videos before they can start. And these can be user-generated video or video created by, but especially for the first case, these recommendations actually help create recommendations for a certain type of role, whether you're a business analyst or you're a software engineer, or you're trying to grow your software engineering, to teach them certain new skills. These kind of recommendations really help. So far as the recommendations have gone, I want to talk about two other topics here. So the first one is content understanding. So a lot of content is being uploaded either by users or by instructors themselves, and learning that content is is very important. But there's a labeling problem. So this comes to the second AI problem of learning with limited label data or no label data, so which is another class of weak supervision, which is semi-supervised algorithms or unsupervised algorithms or transfer learning algorithms. So courses are labeled with skills in LinkedIn ecosystem, and any other learning platform would have a different name like topic or tag, but they're very sparsely labeled. So there are only 2 to 3 skills per course. 2% of the entire skills, taxonomy is actually tagged. So we want to discover more, and this is a problem. Oh, I'm so sorry. I don't know what happened. I don't know. Just ask me to download something. Okay. Yeah, let's try that again. Yeah, I think I'm. Okay. Yeah, I think it came back somehow. Yeah, so there are 2 classes of algorithms I'll talk about. One is semi-supervised algorithms or weak supervision, and the second one is transfer learning. Under the category of learning with limited label data, one of the techniques that we found very valuable was label augmentation. That means we actually augment labels based on the additional sources we have. So we can look at course transcripts, embed them using doc-to-vec models, and based on these embeddings, we can actually create a sort of a map or a graph of course similarity and figure out if a course is labeled as Excel, then another course that's similar to that will also be labeled Excel. And this is a very good way of injecting positive labels. Another one is to actually look at skill similarity, where you have skills that are similar to each other, short stories or prose. And so if a course is labeled a prose, it's probably, or a short story is probably a prose, and so on and so forth. So this also allows us to add further positive labels in the model. So this is roughly what the algorithm looks like. We have human label data. We can augment with positive labels. We can also augment with random negatives, and then we go through the entire feature pipeline that I talked about before. The other problem where this is valuable of tagging content is videos, and videos are usually uploaded by people, especially in enterprise use cases or other platforms where user-generated videos are considered as instruction material. Videos usually have a transcript, a title, maybe some description. They are very useful in recommending videos directly, also in improving search quality. But then the issue is that there's no tagging at all. So here we can use something called as transfer learning approach, where you can train at the course level but score at the video level. So a simple example is you can collect all the video transcripts at the course level. You already have the tags. You can train a model using the algorithm before, and now you can score using the video level. This trend also, has been tagging videos, surfacing videos, delivering videos also has helped. General field I've talked about is that I've talked about before is micro content for micro learning. One of the criticisms of online learning has been the dismal course completion rates, poor, inability to gauge. But then I think the course completion rates is actually unfair, because what we found is that people are usually learning from handheld devices. They're hardly finishing a course, and finishing course is not the point. Learning something is the point. And so with this, we wanted to see. So we ran a campaign called the Daily Bytes campaign. We just wanted to see whether someone can learn in time versus in case. And this is essentially what microlearning is. You're learning in time when you need it, and you're learning in smaller bite-sized content. And we ran a campaign where we disseminated these small videos every day, and we saw a lift in our engagement, huge lift in our engagement, because people are more willing to learn something every day as opposed to learning all together, sitting a whole semester, of course, through Coursera. So how can AI help? One is identifying in your own catalog what could be the standalone video that you could disseminate. And one such algorithm and the other one is, of course, tagging, which I already talked about. In order to identify, you can look at different video watching behaviors, transcript overlap, or things like co-viewing as features to see whether 2 videos are similar to each other or they depend on each other. So we're looking at videos that are separate, that can be disseminated separately without having a link to the other. So we look at some coefficients here, looked at mainly the co-view behavior, and the metadata is what helped us identify whether a video can be classified as a micro-content video. And this can be very valuable. If you already have a lot of videos with you, and you do want to keep people engaged with learning, this is something you want to do. And I want to talk about personalized learning paths, but I don't think I have time, right? 1 minute? Okay, so let me just quickly rush through that. I'll give you like a quick 1 minute spiel. So learning paths are a way, these are something that you get often, where you have you can do this course, then you get the specialization or degree. It's very common. Also, learning paths can be a sneaky way to keep you watching one video from the next, which is what YouTube does, but you could do this in the learning context for a good reason, not for wasting time. What is different about personalized learning paths as opposed to regular learning paths? So in the regular learning paths, they're editorially curated. Someone who knows, someone who's a learning scientist or someone who's been an expert in the field knows how to get to a certain point A to point B, and they create the specialization, but they don't take into account current seniority level, current expertise, current history, job history or skill history. And so that's why personalized learning paths are valuable. And in terms of AI, this becomes a sequence generation problem. And there are two steps to the main sequence generation problem, and this will be my last slide. The first one is identifying the initial set of courses, and the second one is generating the sequence from that initial set of courses. So we treat it as a graph walk problem. The first one is to create the initial views. The two ways is, one quick way is job views. You look at what jobs people have viewed before and what courses are relevant for that job. That could be a good starting point. Or it could be a title transition. So you're a certain title right now. What is your next title? And given the next title, who are the people who are in that group of the next title, and what kind of courses are relevant for them, and can that be a starting point? And the second part is, of course, actually creating a sequence from that starting point. So you create a graph, and you can do what kind of graph walks on this. You could create the graph could be a similarity graph. It could come from co-watching behavior. It could come from collaborative filtering. It could come from course embeddings that you have created from the transcripts. So once you have a course similarity graph, now you have a graph you can walk given the starting point. And you could do a greedy walk, that means go along the strongest edge, or you could do a probabilistic walk, or you could do a personalized walk where you could superimpose your recommendation scores on top of the graph, and now a personalized graph for each person. Some things you may need to do is filtering out. You don't want a non-decreasing difficulty level on these sequences. You don't want them to be repeated courses. You don't want cycles in your graph showing up, and you want topic coherency. You don't want to jump across just because it's probabilistic. You don't want to go from a course on machine learning to a course on piano. So this will be my last slide on this. I will go to the very last slide that I have here, because I don't want to take up more time. I want to leave some time for questions. Good God. I guess this ties in with all the conversation we've had. I'm excited about the future of online learning. Maybe people will be able to get a graduate degree from, by just clicking a button, by taking an entire course. And I've seen people in my own life make leaps and bounds of career transitions by taking courses online and making that change, although they don't have a degree that way. I think the biggest gap here, at least what I see, there's an academic, side of the argument about, enabling learning, but then what about the hiring practices? Because all of this is exactly meant to enable the workforce to find the job they want and keep the job they want and grow in their careers. So the hiring practices are still limited. There are people who are hiring are still going after fancy degrees from fancy universities. How do you actually gauge whether somebody has learned something from an online course in order to be able to do a job the way they should be doing, at par with the bar set from that company? Yeah, go ahead.
Thank you for this. It's always fun to keep updated on what LinkedIn Learning is up to.
Yeah.
And I'm actually going to riff on your what you just concluded. It sounds like you're getting very sophisticated ways of modeling consumption, right? But I don't really see measures of human learning here.
Yes, and actually that has been sort of the theme in the past 2 to 3 years, is that online learning, this is the challenge entirely with online learning as opposed to a classroom where people actually register for a whole long semester because they're with you the whole time. Online learning, especially when there's free content or a fewer dollar charge for a particular monthly subscription, it's a very need-based learning, and it's very informal learning. And so there's no way to quantify for a single piece of information whether they did that. There are quizzes and assessments, which is what we are working on, but even then the coverage is very low, because I myself, I'm talking from my own personal experience. If I want to learn something, I go to look at a video, and when I'm learned, I'm out of there because I need to get things done with that video. I don't have time to sit and take a test and help the person who's giving me the video and telling me, oh yeah, thank you so much, I'm going to give you a video on how I learned what you showed me, right? Like people don't have that kind of time. So that's an area of challenge in the online learning platforms in general, and this has been. There are companies that are doing, to answer the question on the hiring side of it. Like it may not happen right after learning, but there are answers on the hiring side. So there are companies that are purely coming up that are purely based on, you don't have to have any background, you don't have to have any degree, none of it is actually applicable. You just take a test for that company, and once you have cleared the test, you're eligible to work there. So those things may be a better, if there's a way to tie that information in with the courses people took, but even the courses people took are there, it's all over the map actually. Like some people are complementing educations from Coursera to LinkedIn Learning to Udacity to Udemy, so there's no way to really consolidate all that. So there is, just one second, let me finish the point here, there's a company called Degreed that I have talked about. They actually keep track of all that you have learned. They're all like your learning profile sort of a thing. So if there's a way to tie that up into the hiring side, there may be answers to those questions, but with the informal learning, the goal is to be informal learning. You don't have time to really give feedback on how you learned something. So, yeah.
Well, I'm sorry.
Yeah, go ahead.
Just to follow up on that, there are also credentials, so including our companies offering learning credentials, so on different topics. So that
True.
could be somewhere in between there.
Yeah,
as
there is
well.
a Coursera certification that happens, there's a LinkedIn certification that happens on certain things, but at the end of the day, we need a certain assessment.
Yeah, that's what I meant. So
Yes.
an assessment company like
Yeah.
ACT would offer credentials
Yes.
which are based on a formal assessment.
Absolutely.
So that's also happening right now. But my question was actually on the other side. What about the efficacy of the resources? So you know that they learn from all of these sources, and some of them are, Coursera and so on, but some of them could be Wikipedia. So do you have any way at building an efficacy index for the resources?
Yeah, actually, if each person is very resourceful because they have all these sources available to them, and they can pick and choose what's best. And there was an effort on making a recommendation happen, but once LinkedIn Learning became a part of our own, we are selling our learning products, so we can't sit and recommend. But if you have this data with you, you can actually make recommendations. Hey, this person took this course and got this job, so you should do the same. So that's possible to mine. Yeah.
Do we have the microphone somewhere over here? Oh, okay. So we have time for one more question.
I'll hang out here and talk for anyone else that has any
The
questions.
gentleman over here.
Hi. I have quite a bit of research background in the intersection of MOOCs and computer science and machine learning. So you made a lot of analogy between MOOC platforms like Coursera, edX, and what LinkedIn Learning is doing. I see this analogy is not really valid because LinkedIn Learning is not really a MOOC.
Yes.
Yeah. So you are kind of like this Stack Overflow kind of an approach where people are trying to learn things when they need in really short bits of
Yes,
time, right?
exactly.
So, and you don't have this thing called the cohort effect where people learn together. And mainly what I wanted to ask you about was the thing that's missing here that MOOCs have is that learners are forced to learn in isolation. Like they don't have a discussion forum to interact with the instructors or with the peers. So if you don't understand something, there's no way for me to figure out what's going on because I'm learning something completely new, right? So what do you think about that? What are your thoughts? And this is one of the key problems in MOOCs actually.
True. Actually, that's something that we did have discussions about in learning, and we talked about having a learning community where there was like an online community where people could learn together at the new year, and those things fell flat because learning is a really private experience. Learning is a messy experience, and people do not want to often share. I honestly don't want to learn a tough topic with my coworker because he'll know how bad I am at it, right? So I mean, there are those privacy concerns around that. So what we found was that the learning communities is good. The signups are great. Again, the follow through is the problem again of people. What is more useful is something like a Q&A where people can ask questions, and so we're launching that. Shortly,
Right.
where people can ask any question, and then there'll be a question and answer back and forth with other learners responding to those questions of what challenges they faced along the learning. But then I do want to emphasize to the point that platforms that are different from edX or Coursera, like these platforms, are actually tailor-made to workforce. They're not meant for. There are two kind of workforces. What we learned was one category of workforce are career transitioners, people who like to make a long-term career transitions. They'll actually take a long-term course on Coursera or edX or Udacity, like a nano degree, and they'll actually make a career transition over months of time, like years, maybe even a year or two. But people who are actually coming to shorter video content or shorter content, especially LinkedIn, most courses are under 2 hours, which are mostly valuable for freelance community, people who are like trying to develop a website for a client and they need to learn Node.js just on the spur of the moment. They don't have the time to sit through an entire course or one semester to learn. So they're coming there, learning 2 hours and going back. And the other one is also people who are starting in a new job. So if I change my role and I'm starting in a new job and I've never done object-oriented programming in my new job and I want to learn that. So LinkedIn Learning or shorter courses are the right platform for that because they give you the just enough to get started, where you don't have the time. So I think the demography is very different for all of these things. So that changes what kind of learning practices you can generalize. You can't really create a pattern when you have, and especially people who are in transitioning from jobs or making these changes. They're just going to sign up on the site, on the learning site for that period, and they're gone. So it's very need-based. So that changes the kind of predictions you can make. Yeah.
Good. Thank you so much.
Thank you.